Hi, welcome back to General Chemistry 1. I'm Dr. Fang Xu, and today let's discuss the last topic in Chapter 3, limiting reactant and yield. So we need to know what is a limiting reactant and correspondingly what is the excess reactant. Imagine we have this type of reaction, like in reaction we discussed before. So we know before this arrow is reactant or reactants, and after we have products. So from this chemical equation, if I'm going to feed a reaction with 2 mole of sodium and 1 mole of water, is water sufficient so that all of sodium can be reacted? No. Why? Because if we have only 1 mole of water, according to the coefficient, it's 1-to-1 ratio, 2-to-2, that equals to 1-to-1, ratio between sodium and water. So if we have only 1 mole of water, we only need 1 mole of sodium. Now we have 2 mole of sodium. So some of the sodium will not be reacted and all of the water will be used up. So in this case, water is a limiting reactant and sodium is the excess reactant. So how to determine which one is a limiting reactant? As we described before, we need to use the stoichiometry calculations. Try one reactant to see how much the other is needed, and from that point, we can determine which reactant is a limiting reactant. Determining limiting reactant is very important. And if information of 2 reactants are provided, the limiting reactant must be determined first. Because all the stoichiometry calculations needs to be based on the limiting reactant, not the excess reactant. Okay, we want to have you to have the correct answer, not the wrong answer. If you understand the limiting reactant theory, it's more like the law of minimum. This is a barrel with staves, right? So the shortest stave determines how much water a barrel can hold. So the same thing here, the smallest amount of quoted stoichiometry amount reactant determines what product you can maximally possibly make. So remember to determine which one is the limiting reactant if 2 reactants are provided. If only 1 reactant is provided, then we'll assume that's the limiting reactant. Let's take a look at a question. Methanol, CH3OH, is produced from the reaction of carbon monoxide and hydrogen, and it gives you the balanced chemical equation. How many moles of methanol can be produced when 4.5 moles of CO reacts with 7.2 moles of hydrogen? Both CO and hydrogen are reactants. All right. Obviously, it's a stoichiometry calculation. It asks you the moles of methanol and then give you information of reactants, right? But since both reactants are given, we need to determine which one is the limiting reactant. And we're just going to try it out, okay? Assume the CO is the limiting reactant, and let's see just how many hydrogen it needs to completely react with X moles of hydrogen, okay? Then we establish the proportion. 1 mole of CO from the chemical equation reacts with 2 mole of hydrogen, so 1-to-2. And then in the reality world, we have 4.5 moles of CO. We assume it's a limiting reactant and it needs to react with X moles of hydrogen. Cross multiply this, you can solve X equals to 9. Then we can assign which one is the limiting reactant. If CO needs to be completely reacted, we need 9 moles of hydrogen. Now, we only have 7.2 moles of hydrogen. So hydrogen is not enough. So hydrogen should be the limiting reactant. Now we determine which one is the limiting reactant, and all the other calculations should be based on the limiting reactant of hydrogen. So when it asks how many moles of methanol can be produced, that calculation needs to be based on the hydrogen. We can do the stoichiometry calculation. Assume 1 mole of methanol can be produced. Again, do the proportion. 2 mole of hydrogen corresponding to 1 mole of methanol. Now we have 7.2 mole of hydrogen. We are going to have Y mole of methanol and solve what Y is. Y is 3.6. So for this question, we have 3.6 moles of methanol produced. All right, so this is how we solve the question related to limiting reactant. Another concept is percent yield. That's something when we have a chemical reaction. Ideally, from a stoichiometry calculation, we think, well, we're going to have these amount of product. But in reality, all kinds of things can happen. And you may not achieve the amount of product based on the stoichiometry calculation. For example, there are side reactions that consume some of your reactant to something else. So you don't have your ideal product. Or during the transfer, something is lost and you just have these consumes. So people use the percent yield to indicate the how much of the theoretically predicted products are collected. So to calculate the percent yield, we can use the actual yield divides the theoretical yield, right? So actual yield is the amount of product actually obtained. And the theoretical yield is the amount of the same product from the stoichiometry calculation. And when we have the percent yield, it only refers to the product. We can use either moles divided over moles or grams divided over grams. So mass over mass. Either way is fine. Let's take a look at the question. Marble gives you the chemical composition, calcium carbonate. Reacts with hydrochloric acid solution to form calcium chloride solution, water, and carbon dioxide, several products. Find the percent yield of carbon dioxide if 3.65 gram is collected when 10 grams of marble reacts. Okay, so it asks you the percent yield, and obviously we need to know the actual yield and theoretical yield. The actual yield is provided, so it's 3.65 gram. So we can use the second part of the equation. We just need to find out the theoretical yield of the carbon dioxide and in the unit of gram, which means it's in the mass. And then we can solve this problem. So first, we need to write out the chemical equation because the theoretical yield is based on the stoichiometry calculation, right? We need to know how many CO2 can be produced by 10 grams of marble. Okay. Before, when we talk about stoichiometry calculation, we convert everything into quantity, into moles, and establish the proportion. You can still do that in this way, convert how many moles are there in this 10 gram of marble, and based on the stoichiometry, establish the proportion, get how many moles of CO2 is produced, convert that CO2 into mass, and then that's a theoretical yield. That's perfectly fine way to do it. It just includes so many steps. Now I'm going to introduce a new way to establish the proportion. That applies to when you have mass as information provided, and you also need to get the mass of one of the chemicals in the chemical reaction. So now we only assume, instead of X moles, we now assume X gram of CO2 that can be produced. We can establish proportion. Originally, we only have 1 mole, right? But if we want to establish a proportion of mass, that is different from the proportion of quantity. So we need to use 1 mole times the molar mass of marble, calcium carbonate. So if we have this amount of mass of calcium carbonate, we can produce this amount of mass in CO2. So we use 1 mole, that's the coefficient from CO2, times 44 grams per mole of CO2, the molar mass of CO2. So from these two, use a combination of coefficient and molar mass, we can get the mass proportion of mass for any of the two chemicals in a chemical reaction. From that, we can plug in the mass here. So now we have 10 grams of marble, and we need to know how many grams of CO2 are there. From this proportion, we can cancel out these 2 moles. So on the left, the net unit is gram on top and it's gram in the bottom, right? And we take the coefficient into consideration. All right, so from the left, again, it's from whatever from the chemical equation. On the right is from the question, and all the 4 components has the same unit in gram. So that's good. In this way, we can calculate the X that equals to 4.4 grams. That means when 10 grams of marble reacts completely from the stoichiometry calculation, we can produce 4.4 grams of CO2. Then finally, can calculate the percent yield. Use the actual yield divides the theoretical yield. 3.65 gram divides 4.4 gram, and then we can get the yield, percent yield is 83%. All right, that's the end of chapter 3. I'll see you later in other videos. Bye.